Okay, and you're live.
Hi, everybody. Good morning. Thanks for joining us today. My name is Emily Chasan. I have been a journalist covering sustainable finance for the past 6 years at Bloomberg, the Wall Street Journal, and elsewhere. And I'm currently communications director at a company called Generate Capital, where we are very focused on energy storage and infrastructure and solutions. So I'm really excited to have this energy storage panel today with Marek, Mitalee, and Andrew. I'm going to let each of you guys introduce yourselves. Let's start with Marek. Tell us a little bit about who you are and what you're doing and how that relates to energy storage.
Yeah, sure. Very happy to. Thanks, Emily. So good morning, good afternoon, good evening, depending where you are in the world, tuning into this live stream. So I'm Marek Kubik. I'm market director at Fluence. And Fluence, for those of you who are not familiar with us, we're an energy storage technology and services company. So put very simply, we design, install, and then long-term service and maintain the performance of really big battery energy storage systems to help integrate renewables to the grid. My role personally, so I lead our team for UK and Ireland. Essentially oversee everything up to contract negotiations and signing of these big battery projects with various customers, so developers, utilities, and so on. And been involved in the space for about 10 years through different roles, originally on the development side and now on the technology provider side of things. So very happy to be here and to be part of the discussion we're going to have.
Great. Let's go to you next, Mitalee.
Thanks, Emily. Hi, everyone. I am Natalie Gupta. I am a senior energy storage analyst with Wood Mackenzie. Wood Mackenzie, we are a market research and consulting firm providing market intelligence on a variety of topics, including power, solar, wind, energy storage. I have been working with Wood Mackenzie for the past 3 years, largely tracking energy storage supply chain. So kind of understanding how the supply chain is evolving across the globe, and then also tracking different systems and technology. A part of the work that I also do with Wood Mackenzie is doing some price forecasting for energy storage systems. So I look at prices for not only batteries, but also for non-battery or balance of system components. Very excited to join this discussion today. Thanks so much.
Thanks so much. And Andrew, our last introduction.
Yeah, thank you. And likewise, good morning, good afternoon, good evening to so many folks joining us from around the world. Certainly sprightly 5:30 a.m. here in San Francisco. So I head up the commercial side of Yotta Energy. We are a commercial energy storage manufacturer. We manufacture a 1 kilowatt-hour battery, similar to the one you see directly behind me, that actually installs directly beneath solar panels and provides a distributed form factor, which I'm sure I'll get into in greater detail. I've been in the energy storage and renewable energy industry for about 20 years. I often joke, 20 years ago at university, I wrote my thesis on energy storage. It was just thermal energy storage for concentrating solar power, which was the wrong storage for the wrong solar. But clearly the right idea. So I've been in solar and energy storage broadly for about 20 years. Prior to Yotta, I was with a company called Jelly, who many are probably familiar with on the software side of things. So I've got a pretty detailed knowledge of certainly distributed and commercial energy storage applications.
Great. Well, my first question is about 2020 and sort of thinking about the energy transition this year. Because when we started the year, it seemed like energy storage was finally starting to scale up. It's not been a straight line for energy storage, but it was really starting to go. And then, of course, COVID happened and the transition. I'm curious from your perspective. Let's start with you, Mitalee. Tell us a little bit about what's going on in 2020 and what's the overview of what the market looks like in energy storage.
Yeah, sure. And that's a great question. So overall, the market, I mean, it started pretty strong earlier in the year. Q1 was pretty good. We saw significant deployments earlier in the year. However, there were some slowdowns that started trickling in sort of around March. So we saw some delays around project construction, project commissioning. Some delays started happening over there just because of like lockdowns and, you know, travel bans, all those things that were sort of imposed all across the globe. Also on the supply chain side, because of the lockdowns that were happening in China earlier in the year, there were some supply constraints that happened in terms of like battery availability. But the market actually recovered pretty quickly from that. So we didn't see much shortages sort of happening around product availability. So overall, the market recovered pretty swiftly around battery supply chain and manufacturing. But on the downstream side, there were some delays that were expected. However, now that we are in Q4 of the year, we are still seeing the projects sort of go forward. A lot of, the markets have recovered pretty swiftly from all the delays that were heard earlier in the year. Some projects have obviously been pushed out, but I think that's more on the non-residential side of things, especially for front of the meter market for larger projects. I know most of the projects are moving along. Some delays, some shorter delays here and there, but overall we expect, at least on a global perspective, we expect 2020 to be a much stronger year than 2019 actually. So at Wood Mackenzie, we are forecasting about 80% year-over-year growth this year. 2019 was a much smaller market in terms of deployment.
Great, that's a great overview. Yeah, Marek, could we go to you? Could you tell us sort of how you're seeing some of those trends play out in the market from your perspective?
Yeah, sure. So I think it mirrors a lot of what Mitalee has said that we see from the bottom-up perspective of our own projects. So despite the challenges of the pandemic, we've continued to enjoy exponential growth. So Florences has been around now since deploying the first grid-scale battery system in the world back in 2008. So over the last 12 years, we've been growing, and each year, as you'd expect, that market share grows more and more by megawatts. But each year, we tend to look back at all the cumulative previous years put together and find that we've done even more than that in the 1 year alone. So that trend has continued for the last few years, and so again, it's been a very strong one. It really represents this exponential growth path that we're seeing for the use of storage right around the world. So despite the challenges of the pandemic, which I think fully agree, there's been issues both on the supply chain side of things, because as factories shut down, there's constraints around availability. We've been pretty well insulated from that, largely because we have a very robust supply chain. We're horizontally integrated as a technology provider, so we're not tied to any one chemistry, technology, supplier, or factory, which gives us a lot more resilience to be able to manage some of those local constraints where there have been lockdowns. And then really the other aspect of project deliveries that becomes challenging is if you're in the construction phase and actually on site, which is actually a relatively short period in the overall timeline of a project. Those have been affected by social distancing measures or restrictions on coming to site. So there's been aspects to manage, but broadly speaking, this year we've been managing something like 70 projects at the same time around the world. So it's a pretty substantial number, and virtually all of them have are roughly on track. There's been limited impact across them. So yeah, I think same perspective from a different angle.
Great, that's really helpful. Andrew, I guess you mentioned resiliency, Marek, which is really crucial in the energy storage market. Is sort of like one of the goals. And coming from California, Andrew, I'm sure that's something that's propelled energy storage this year, and just the desire to keep the market going. Could you talk a little bit about your COVID experience in the market?
Yeah, absolutely. We've seen for those who aren't familiar, in California, there's a program called SGIP, which is the Self-Generation Incentive Program. And it's been the program that's provided a rebate to energy storage systems for distributed applications. And it's been incredibly successful. But I think the mega trend that we've seen continue and in fact get worse is that there's been broad adoption of energy storage for residential applications where it's very cookie cutter. And then we've seen increasingly developers in market, the STEMs, the NLXs, the NGs, focusing more on systems that are megawatt hour and above. And you've ended up with this gap in the market, in the sub megawatt hour, sort of the mid-market, small commercial. And the statistic that we extracted from interconnection data is that if a solar installation is under 500 kilowatts, in fact, 92% of solar installations on commercial rooftops are under 500 kilowatts. Your adoption of energy storage is only 2%. Whereas if you're above 500 kilowatts, the adoption's been 25%. So it just shows how neglected this sort of, small, medium commercial market is, and we've seen that that trend continue. Positively for the industry, we've seen this year, in fact, about 7x growth in the amount of actual reservations being filed for energy storage, which has been driven largely by resilience and a little bit of additional rebate to support those that are exposed to public power safety shutoffs, or whatever the acronym is, with PG&E and others. So, and of course, we've seen the historical bushfires here in California. I was, in fact, in Australia in January, so I got a double whammy in 2020, Australia's worst bushfires ever, and a hazy sky in Sydney for a month or two, and now San Francisco with hazy sky for a couple of months. So definitely resilience is going to continue to be front and center, and we're certainly looking forward to deploying our technology and addressing that mid-market that's being neglected right now.
Great. Well, let's go to the cost part of the conversation and talk a little bit about the cost curve in energy storage. Maybe we'll start with Marek. You could go into a little bit about, how the industry is adapting to that. There's definitely been a cost curve coming down. What do you see as the challenges there and the opportunities?
Yeah, it's a great question. So a lot of, the industry itself, I think we've even used it already on this conversation, that there's the year of storage and it's always this year, and we've said that every year for the last few years. And I think it just continues to be like there's more and more things that energy storage is being found to be useful for, and that's partly because of growth of applications and increasingly on the regulatory side opening up markets to batteries. But the large part of it has also been, of course, the cost trends, that the fact that these technologies have been getting cheaper very rapidly compared to the adoption rates that we've seen historically, over the last hundreds of years in the power sector have taken a very long time. And now suddenly it's really been a huge change over the last 10 years. So I mentioned that, the first commercial projects we brought online were around 2008, 2009. And these were, actually, funnily, because we might get onto the battery chemistries and things, those were LFP batteries back then. And 20-minute systems, so short duration, and 10 megawatts, 12 megawatts, something like that, they were over $6,000 per kilowatt. So absolutely, I guess, compared to where we are today, eye-watering costs, yet they were still being found to have very quick returns if you could find the right application, because some problems are so, painful that these solutions were actually solving them and doing so in a very cost-effective way. Now, batteries have been one of the largest parts of the storage system cost, dominantly so over the past 10 years. But as they've been falling year by year, we're starting to get into the territory now that we saw with solar PV, just sort of echoed maybe 10 years earlier, which is that the battery costs, your analogous solar panel cost as a percentage of the system is, still the most significant component, but it's getting to be not your be all and end all. So everything before that we were doing was really focused around what can we do to bring down battery costs. Now we're starting to think about what about everything else, and really actually it's the balance of system side of things that you have to really look at how to bring down the cost. And recently in the last year we focused a lot on that. We launched over the summer what we call the Generation 6 platform, so the 6th iteration of, I guess, our energy storage containerized design, which moves a lot more towards a factory standard form factor that you can basically use as Lego blocks to build any type of system, any duration, behind the meter, front of meter, without having to re-engineer stuff. And so we see a lot of focus now on that and driving efficiency in the rest of the value chain that goes with the batteries, to keep bringing costs down further and to keep enabling this sort of scalability towards the gigawatts and ultimately terawatts of energy storage that we need over the next few decades.
Yeah, Natalie, thank you, Mark. From your viewpoint, what's going on in terms of the cost curve in energy storage, and where do you see costs coming out? Where do you see challenges in the market as they respond to lower prices?
Yeah, absolutely. And I think I have similar perspective as to what Marek just said. So in terms of what we've seen historically, the prices for energy storage systems for batteries, they have come down pretty rapidly. Over the past 8 to 10 years, we've seen prices drop by more than 65% at system level, and at battery level, the prices have actually declined by more than 85%. So we've seen significant drops over the past few years. However, now we expect the market to sort of enter this phase, this new phase of price decline, where we'll not see a significant drop on a year-over-year basis. So the price declines that we are forecasting for the next 5 years or so, there would be more in the range of 10 to 12% on a year-over-year basis. And the drivers for those price declines would be different from what we saw in the past. And kind of similar to what Marek said, historically, it was largely batteries. The prices for batteries were sort of coming down pretty quickly. That was kind of, accelerating this decline in system level prices. But going forward, it's more the balance of system components, the non-battery components that are going to play a major role in bringing down system prices. So we expect, a lot of innovation to kind of happen around system designs, system architectures, a lot of, activity happen around how these projects are getting deployed in the field. A lot of vendors are kind of focused around, achieving savings over there. So that's obviously, one of the things that's going to bring down pricing over the next few years. And overall, we expect the market to see about 30 to 35% of price declines at system level over the next 5 years. And like I said, it's driven by, a variety of things. Batteries obviously still would kind of contribute to that, but a lot of it would come from balance of system components.
Great, that's really helpful. Andrew, how do you manage this and stay on the right side of that cost curve?
Yeah, we, going back to that analysis I mentioned of data sets like SGEP, we see a massive spread in the dollar per kilowatt hour installed in the sub-megawatt hour market. You get to a megawatt hour and suddenly that distribution is very tight. But we're talking about thousands of dollars per kilowatt hour, down in the couple of hundred kilowatt hour range. And, our technology exists really to disrupt the balance of system and the engineering component cost that exists and overwhelms smaller energy storage projects. Our product, it installs, in fact, you might even see it installs on the ballast racking of PV systems. So we actually use the weight of the battery to our advantage. So we substitute for concrete ballast blocks that would otherwise have to go onto rooftops. What that means is the marginal cost to get that battery onto the rooftop is almost zero. Similarly, we actually installed the PV panel directly into the unit, and we do the optimization for that solar panel on our power electronics. So we're not only DC coupled, so more efficient than AC coupled energy storage, which I've quantified the NPV to be about $70 a kilowatt hour of benefit over a 10-year period, just from having a more efficient design architecture. But we're replacing and substituting hardware that you'd otherwise be required to isolate PV panels and do optimization as well. So we're reducing the cost of the PV. And actually, lastly, and this is a really cool innovation, and you're seeing this more broadly at utility scale, but not at a distributed level, is that we can actually enable DC ratios to be pushed up to 2 and above. And what that means is that we can, in fact, connect 2 solar panels into each one of our 1 kilowatt hour units, reduce the amount of solar inverter and other electrical balance of system by 40% by pushing the inverter harder for longer. But we're converting a bell curve solar production into a tabletop. And so we almost eliminate the complexity associated with where the installation is going to go. how it's engineered, because it's sharing the same interconnection as the PV on the DC side. Much higher efficiency, and then we're actually reducing the cost of the PV installation. So we're looking at this from a system perspective and not just from a technology perspective. And certainly, you know, we're in the process of going through UL. So we are Q1 next year is when we'll officially be able to start interconnecting these batteries, and we're very excited about the market potential, because we see in this sub-megawatt-hour market both a neglected market as well as just a ridiculous spread and complexity associated with how you engineer, where you deploy the batteries, and we address all of that head on with our approach.
Great. Yeah, you've all sort of brought up design changes and design thinking in this space, and also thinking about the system and how it would change overall. One thing that's been brought up to me is like wondering whether energy storage is actually getting paid for the service that it's providing the grid, and how to think about that going forward also. I'm curious, maybe Marek, you could talk a little bit about just looking out into the future. You know, where is the system of energy storage evolving, and where do you see things really pushing on that front?
Emily, do you mean on a hardware sort of perspective, or do you mean from a grid applications perspective? So what you use storage
Probably
for?
Both.
Both? Okay, I'll have a go at both. So I'll start with the application side then. So like this is sort of really like, I guess, the pull factors, like what things do you need batteries to do now and or in the future on the grid? And I mean, I think it's been said many times before, storage is the bacon of the grid, the Swiss Army knife of the grid. It just, you know, it makes everything better. You can use it for so many different things. That's partly the challenge, because there's so many different applications that you can set up and configure an energy storage system for to do. Now, I'll pick up, I guess, a few of my favorite front of meter trends that I think there are really interesting, well, not even proof of concepts, I would say, commercial projects that have you know, found their way through the regulatory barriers to become commercial reality. That could spread very you know, very quickly if the, you know, right conditions emerge. So the first of those is actually around virtual transmission. So traditionally, storage has been used for things like grid services, so ancillary services to help you know, balance supply and demand. It's a low-hanging fruit that that batteries can do much better than thermal power plants, which historically have done it. But what we're starting to see now, as we move towards this, you know, transition to you know, 100% sustainable energy in a clean grid, is increasingly distributed and variable generation all over the place, and needing to be able to transmit the power from where it's generated, which is often, unless you're looking at sort of community energy, in the UK and Ireland, it's typically offshore, or for instance, in Ireland, one of the markets I cover, the wind is all on the west coast and all the demand centers are on the east. And building new transmission lines between places is very difficult and expensive, and, you know, takes frankly decades because of all the, you know, the planning, the billions that go into it, the environmental impact and so on. So using batteries to actually replace or supplement, enhance the grid by managing congestion and constraints on lines that would otherwise be overloaded and require additional investment is a really neat solution to a very big challenge that we're going to face as we get towards this, you know, next decade of getting to, you know, 70-80% renewables and ultimately 100. So that's a really big area. Peaker replacement is huge in the US. You know, that's a very obvious one, replacing generation that is, you know, dirty, expensive, and runs very infrequently and for short hours when it does. And then, you know, UK and Ireland wise, I think the other key one that we're starting to see now is, as you get towards, you know, Ireland, for instance, has a 70% renewable electricity target by 2030. In order to get to 70% renewable electricity on average over the year, you'll have periods, of course, where it's not windy and not sunny, and it'll be low. So there are periods now where you have to nearly have 100%, you know, 90-95% of the grid running on wind or on you know, non-synchronous technology, so not thermal generation, and that requires a lot of new insight, innovation, and new technologies to come along. And one of the ones that I'm personally very excited about is using batteries for things like digital inertia, super fast frequency response to help stabilize the grid in these sort of environments where you've got a lot of, you know, variable generation that doesn't have this, you know, inertia, this momentum to keep the grid going in the same way a thermal power plant does. spent quite a long time on the application side, so maybe I'll pause there and we can come back to the technology side.
Yeah, we can go back around for the technology side. That's a good point. Let's do applications all around first. But yeah, I guess it's interesting what you're talking about, because right here in New York City, they've been talking about making Rikers Island like a wind and solar hub for a long time, and now they're talking all about it becoming a battery hub, right? Because what we really need is stability in the grid, and you need to replace those peaker plants. So that's really interesting to see. Mitalee, I'm curious on the application side, where do you see things going in the next few years with storage? And
yeah, I think Marek mostly covered most of it. So yeah, for the US market, obviously peaker replacement is something that's coming up quite a lot. The other one that I think is also becoming important in most markets is renewable integration. So with more and more, solar and wind kind of, making up the grid, renewable shifting is becoming more and more apparent, and the need for storage to be used, to be paired with your solar or with your wind is becoming really, really important. And not just in US, like I said, like in most global markets, we are seeing, significant hybrid systems in Europe, UK, Germany. A lot of these markets are looking at solar plus storage, even Australia and China. We've seen significant deployments of solar plus storage projects as well. So yeah, as we see greater renewables on the grid, definitely, storage is going to sort of become more and more important. And I think then it's just like the need for greater system flexibility. Storage helps offer that value stream as well, where you can deploy your storage for system flexibility. So we are also seeing that kind of, come up in a lot of different markets. But yeah, overall, yeah, it's mostly where Marek just mentioned, the market is kind of headed in that direction, where we're seeing storage getting deployed for pretty much most applications.
Yeah, Andrew, I'm curious from a systems perspective, what do you see as the big shift happening in the next few years? You can talk about applications first here,
yeah,
and on technology.
Yeah, when I joined Jelly back in 2014, I think Rocky Mountain Institute was coming out with the famous wheel of all the different applications that energy storage could be used for. And, value stacking was only just starting to be talked about. I think if you fast forward to 2020, what you're now actually seeing is the ability to contract for each of those different value streams, and sophisticated energy management software platforms actually being able to do the co-optimization for those different values. Distributed energy storage is, I guess, positioned to capture more of those value streams than any others. And so we're very excited by that trend now to actually be able to monetize for those different components, because of course, you can be working very hard to bring down the cost of the technology and the integration and whatnot, but if at the same time you're increasing the value that the system can deliver, you're going to be improving the ROIs of the technology. So very exciting to see the ability to actually now contract for a lot of the values that we've been talking about for a very long time now materialize, and niche companies emerge focused at enabling companies like Yotta to contract for them. I think the other thing to keep in the back of your mind is, as distributed solar in particular proliferates on distribution networks, you are going to see greater challenges with high penetration PV networks, and in many instances, mandating of energy storage in order to soak up that additional sun. You're also going to see a lot of tariff reform from the utilities to fight that, that surplus of energy their networks are going to see in the middle of the day, which, and pointing to California, you've seen a shift to, of the peak period 4 to 9. I think broadly you're going to see that trend expand across many markets, not just in the US, but broadly around the world. So, this is only going to increase the value proposition for the energy storage even further. So I think it's really exciting on the revenue side to see, where energy storage is now compared to where it was and where it's going to.
Great. Yeah, I saw Mitalee nodding as you were talking about the relationship between storage providers and the utilities. Just curious if you could talk a little bit about where you see that going, Mitalee.
Yeah, so I think a lot of what we are seeing now is just with like the higher penetration of solar, like a lot of RFPs now that are announced have a storage component in them. Either they are like a solar plus storage RFP or they have some sort of like storage component in them. And even just like overall in terms of like IRP planning that the utilities are doing, we are seeing, utilities kind of look at storage in a much more as a technology that that could definitely provide for a lot of applications. So yeah, the view that utilities have for storage has changed a lot over the past like 5 to 10 years, where we've seen them look at storage as something that could be a game changer, that could provide for different applications that could help resolve a lot of the issues that around like transmission and distribution deferral, etc. So yeah, a lot of the view of the utilities has sort of changed, and then they've become more amicable to storage, I guess, where they're viewing storage now as a technology that could be pretty useful.
Yeah. Andrew, I want to have a follow-up question from you too. Oh, we lost Andrew for a second.
I'm still here with the audio. Sorry,
no worries. Let's go to Marek.
Can you guys still hear me?
We'll come back to you, Andrew.
Okay.
Marek, let's go to you and talk about technology, then I'll come back to Andrew. We'd love to hear some of the technology innovations that you're focused on in the space.
Sure. So yeah, and that's a really interesting one to look at over the past 10 years as well, and see how it's changed, because it links back to the earlier part of the discussion of well, really, I guess, taking lessons and then iterating and continually improving and continually finding ways to do things better. So we looked at some of the earlier projects that we did. Well, some of them were containerized solutions, and some of them were in buildings. But I think increasingly, as we're seeing this need and trend towards scalability and repeatability and standardization and moving work really as much as possible into the factory and out of the field, that has big benefits for helping ultimately bring costs down over time. So, if you take the example of a building solution, if you look at some of the, a lot of the operational battery systems from 5 years ago or earlier, a lot of them are in buildings. Why? Well, with buildings, we can design essentially the whole envelope of the system pretty flexibly. And given the batteries were the vast majority of the components anyway, it didn't really matter so much what the remainder of the cost was. But as you try and expand that model into more markets, more countries, more regions, you get into all sorts of problems, because you'll find that local planning, building codes, regulations, things like that start to really slow you down, because everywhere is different. So if you want to create something that's standardized and replicable, you can't really do that with that sort of model. And that's why we've very much moved away from buildings, except in exceptional circumstances, because you get into these funny situations where, for instance, the building code says you've got to put in insulation in your building. And what do you want to do with your building? You want to keep the batteries cool. So you're building an insulated building to cool it down even more with a cooling system, which obviously makes no sense whatsoever. So we saw that sort of as the first wave, and then there was this move towards walk-in containers, sometimes overbuilt. A lot of the projects in the US were custom built and then delivered to site. Again, that doesn't scale internationally, because you can't ship non-standard building blocks essentially around the world. And then partly for safety, density and efficiency reasons, that we moved from containerized designs to actually non-walk-in units and smaller building blocks, these cubes. So this is space saving, because you don't need to leave an aisle down the middle of your container to walk in to get to your batteries. You only service them from the outside. That also has the dual benefit from a safety perspective, that no one can be in there, because there's no reason for anyone to be inside. And it's space saving, because then of course you're just fully utilizing each building block you have. So all of those sort of benefits we've learned over time and through, I guess, experience of deploying projects over the past 10, 12 years of how do we continue to keep bringing costs down. It's, well, improving repeatability. And, if you move to this cube form factor, which we now have, it's about 8 foot by 8 foot by 8 foot, 2.5 meters by 2.5 by 2.5 for our metric colleagues around the world. That's, you can ship multiple of these in a normal shipping container, but then you can assemble them to any length, any width that you essentially want. So you're not constrained on site to delivering a 1 hour, a 1.5, a 1.7 hour, 3.5 hour system. So maintaining that flexibility to meet any grid application, rather than going down the vertically integrated product route where you might have a system that can only do 2 hours or 4 hours cost effectively. So that's sort of, I guess, a whirlwind overview in terms of form factor, and I guess there's a lot more other components, but again, I'm conscious of not prattling on too long. So
could keep going on the design elements for a while, I'm sure.
Mitalee,
let's go to you. I'd love to hear what you're seeing from a design perspective and a technology perspective, looking at as you look out over the next 5 years.
Yeah. So from a design perspective, I think Marek pretty much covered most of it. So we are definitely seeing this shift in the market towards, rather than from like the big containers that were used back in the day, ISO shipping containers, we are seeing market kind of now move towards smaller cabinets, like the product that Fluence just launched. Again, like a lot of the benefit is just, scalability, repeatability, easy installation on site. It helps, helps project developers kind of save a lot on costs, also on their time and resources. Also, I think a lot of it is driven from the safety perspective, because I think everyone in the industry is aware about the fire incidences that happen in South Korea, and also the incidences that happen in the US a couple of years ago. So I think everyone is cognizant of the fact that there is an inherent fire risk with batteries because of the high energy density, that comes with these batteries. So vendors are pretty much focused on making sure that fire safety isn't compromised in these systems. So they are trying their best to design these systems in a way that they are safe going forward. So as Marek mentioned, we are seeing a lot of those changes where the containers are now becoming walk-free. They can only be accessed externally, so there isn't anyone actually walking into the container. So we are seeing all those shifts happen as well. I think I'll spend a little bit time talking a little bit about what we're seeing on the technology side. And this is something that was earlier brought up in the discussion. So from the battery perspective, we are seeing some very interesting advancements and changes happen, which are actually going to impact the overall system design architecture, as well as the cost curve as well. So from battery technology perspective, historically, like this is like very, very long ago, as Marek mentioned, the earlier projects that Fluence did, like the technology that was used in the storage industry was LFP, lithium iron phosphate batteries. But over years, as nickel, manganese, cobalt oxide batteries, or NMC batteries, as we call them, as they kind of ramped up, especially as South Korean vendors like LG Chem, Samsung, they ramped up production. We saw huge demand of these NMC batteries for EV applications. These batteries also started making their way into the storage market. And then by around 2017, I would say there came a time where NMC was sort of the dominant technology in the market. We saw NMC make up for more than 90% of lithium-ion battery systems, and LFP had a very small share. But over the past couple of years, we are seeing this renewed interest in LFP batteries once again. And there are several reasons for that. I think the primary driver for that was there was a little bit of supply crunch in the market a couple of years ago. Again, kind of happened because the demand in South Korea surged, and it was pretty unanticipated, where because of the renewable incentives that were introduced by the South Korean government, the demand just like spiked pretty quickly, and the vendors weren't able to keep up with the supply with the demand, and so there was a shortage in the global market. And that's when a lot of battery system integrators and developers started looking at LFP batteries, where they went back and looked at the technology and evaluated that actually this technology now makes sense, not only for power applications, for short duration systems, but also for energy applications, because a lot has changed even with LFP batteries over the past few years. A lot of Chinese vendors have come to the fore where they are, developing this technology at state-of-the-art facilities. The energy density of LFP batteries has also improved pretty significantly over the past few years. The technology itself is also changing, where vendors are completely eliminating, they're making a step change where they're moving from cell to pack technology, which is actually helping them, bring down pricing and improve the energy density of the batteries. So a lot of advancements have happened with LFP, because of which we've seen a renewed interest in this technology. And that's what we kind of are forecasting for the future, is the market is going to see this diversification where NMC is not going to be the dominant technology in the market. We'll see, LFP or even like other advanced lithium-ion chemistries sort of make their way into the market, which is going to bring down battery prices and going to impact the overall system costs as well. The other aspect to this shift in, this diversification of chemistry is also the fact that everyone is trying to eliminate cobalt from, the battery mix, because we all know, the issues with how the way cobalt is sourced, and it's, largely coming from Congo right now. So there are multiple issues that exist. So everyone is focused on, trying to make sure that we are sourcing batteries. We are manufacturing batteries in a way where they have minimal cobalt content or actually no cobalt at all. And the other driver for that also is just, vendors trying to improve energy density. So they are actually playing around with the metals that can be used. So they are making changes to the cathode chemistries. Vendors are making changes to the anode chemistry. At Tesla Battery Day, we saw a lot of those announcements. Tesla is doing a lot of that stuff where they are changing the cathode, the anode. So battery OEMs are kind of, playing around with different metals. They're playing around with the way, they can introduce design changes in cells and batteries, and improve the energy density of the batteries. Overall, again, this is going to have an impact at system costs. So like I said, huge advancements happening. Vendors are pretty much focused on trying to, figure out a way where we can bring down pricing as going forward.
Yeah, Andrew, just a few minutes on that. That was great, Mitalee, to hear such a great rundown on the chemicals and the changes in chemistry happening in batteries. Andrew, just where are you focused on technology, just for a few minutes, and then I want to do a last wrap up lightning round type of question.
Yeah, sorry about the technical difficulties. Seems like Murphy is even up at 6 a.m. here in San Francisco. So we're at the extreme end, I guess, of containerization. We are wrapping every single kilowatt hour in its own independent container. And historically, people have not put batteries under solar panels because it's really hot. It gets up to, 130 Fahrenheit for those in the US, or about 60 Celsius for those working on the metric system. That's not a temperature that batteries like to see. Our core innovation is what we call a phase change heat exchange technology, which integrates a phase change material which has a melting point around about 38 Celsius or 100 degrees Fahrenheit, combined with insulation and a unidirectional heat exchange design, which prevents the battery from really exceeding about 40 degrees Celsius or 100 degrees Fahrenheit, even in that extreme environment. Now, the first thing we do is we actually insulate the enclosure and the battery pack with a ceramic material, which just so happens to also double as a layer of fire insulation as well. So we've ended up with a pack that ironically is 3 foot center or 3 foot apart. So the distance between those two is a bit more than 3 feet in each direction, which the standard calls out as the distance that you need to space packs apart to be safe from propagation from one to the next. Similarly, we're actually below the battery capacity called out by FDNY, for example, which is 2 kilowatt hours for small. So we're in this like a bit of no man's land when it comes to the standards, but what we're actually doing is distributing batteries over a very large area, which is in fact the safest thing that you can do. So when it comes to safety, really, we don't think that there is a better approach than Yotta's. We've also taken the approach of using LFP for extra safety precautions, and we're anticipating to see increases in energy density over the coming few years. This product right now is 1 kilowatt hour. We're anticipating to see an almost 10% improvement in energy density through improvements in cell design, as well as from product redesign ourselves, such that by 2024, it's probably going to be around about 1.4, 1.5 kilowatt hours per unit. And that's, a 30+% reduction in the cost really of our product, when you consider that there's also going to be cell reductions as well. So a lot of encouraging signs from our perspective, and yeah, we're looking forward to putting the cat amongst the pigeons and showcasing our technology in 2021 on a larger scale.
Yeah, it's been really interesting to hear all the developments in technology and design throughout the conversation. At Generate, we're obviously really interested in what's going to take this technology and make it scalable and repeatable, as scalable as wind and solar have been. So whether that's finance or whether that's design or safety concerns, we've definitely heard about all of that throughout the panel. So I'd be curious from your perspective, just sort of a lightning round to wrap up. What's going to scale in energy storage and what's not going to scale? Let's start with you, Marek, and go really quick, and then we'll go to Mitalee and Andrew to end.
If you want me to be really quick, I'll put it in 2 words: mass customization. And probably need to
explain it a little more.
I'll explain it in a couple of sentences. So we're seeing a lot of the industry, because one way you can create scalability, repeatability is a fixed product. Like it's fixed on a specific chemistry, a specific size, a specific form factor, a specific duration. But that's one half of the equation. It's a one size fits potentially some. It's not a one size fits all. We've talked earlier in the panel about a lot of different applications, and each one of those applications requires a different setup. So behind the meter batteries compared to transmission alternatives compared to frequency regulation batteries require different chemistries, different setups, different C rates, different heating, different cooling. So mass customization is really what we focused on, which is the standardized building block that you can put in a factory, make hundreds and thousands of them, but then configure with the different chemistries with a suite of different applications in an app store, and then basically play with your Lego blocks to build any kind of system you want for any scale anywhere around the world. That to me is ultimate scalability.
Awesome. Great to hear. Mitalee, what's going to scale, what's not going to scale in energy storage, if you have to answer pretty quickly?
Yeah, so yeah, I think it's mostly product standardization, kind of aligning with what Marek said, because up until now, I think the market has seen more bespoke projects, more bespoke, products, where again, like one-off installation, depending on type of project that a developer is doing, they would develop the system, it would have a different system design and engineering. The market has been very bespoke, pretty much all across, different components. I think it's more product standardization that's going to drive scalability in the market. And I think it's also just good partnerships that we are seeing. So a lot of vendors are moving towards vertical integration. There is still horizontal integration in the market, but a lot of vendors are moving towards vertical integration. So I think partnerships are going to play a very crucial role in helping, the market kind of scale up pretty quickly, because we are projecting massive growth over the next 10 years. And that's not going to be achieved by, just one or two vendors kind of taking up everything. So it's a lot of different players that will become important, that are going to play a major role. So I think partnerships would also be a crucial driver for future growth in the market.
Great. Andrew, to wrap us up, what's going to scale, what's not going to scale in energy storage as we look out?
Yeah, so I feel like in the the commercial market, certainly that we're focused at, we're anticipating to see increased decentralization and following a lot on the trends of solar. Right, we've seen what used to be centralized inverters used on buildings. Increasingly, it's at string inverters, and we've got a hypothesis that it's going to increase, and you're going to see microinverters increase and proliferate into not just residential but commercial applications as well. I think our technology is looking to very much replicate how developers lay out solar panels. They lay out batteries, and they optimize to the kilowatt hour based on a building's needs and the value that can be derived from other grid services. I think there needs to be a standard approach. These bespoke costs have been holding back the industry. The United States historically lagged the rest of the world in sort of addressing those balance of system cost components with solar. My home country of Australia, on the other hand, absolutely crushed it. But the US, I think, has been more on the forefront when it's come to energy storage. So it's going to be exciting to see what knowledge from solar actually trickles it down into the energy storage market as well. Because while solar plus storage really sounds like they're brothers and sister technologies, I think for the most part they've really been very different applications of two different technology sets, and we're looking to fuse the two together and come up with a systems approach that's very simple to deploy.
Great. Well, thank you, all of you, for a really wonderful conversation. It's great to hear about the systems approach, how the system is changing, what's going to scale, and all of your insights on technology throughout the conversation. So thanks for joining us today, and hope you get back out there and keep building energy storage. Have a good one.
Thanks so much.